Yeah, so again, so by default, all the interfaces off of the switch, let's see, by default, you have VLAN 1 and all these ports assigned to it, see? By default. And let's see, interface 1 is shut down. Okay, so it's pretty straightforward, the switch. Out of the box, it's ready to just be plugged into VLAN 1. Minimal config here, minimal config in the ASA. So we did get the interfaces down. Now what we need to do is talk about DHCP, because we're at the end user, right? And what we can do is we can statically give it an IP address, right? So let's give it a 192.168.1.34 or something. Yeah, /24. It needs a default gateway. Essentially, it needs a final destination where it says, hey, listen, take this traffic that I'm trying to go to, the destination of a traffic, and I need you to handle it. I don't know what to do with it. And I need to throw this at you. So when that happens, let's say you're pinging, it will be encapsulated as a VLAN 1, and then the switch doesn't care about anything else. It says, oh, VLAN 1, where should VLAN 1 go? Oh, wait, here. There's VLAN 1 and this 5505. Let me just dump the traffic. VLAN 1 dumps it here, and then the firewall then makes its routing decisions and sends it outbound at the layer 3 level. But again, it needs a default gateway. It needs this address, right? So that it knows how to get to its destination. Without a default gateway, the traffic it'll be stuck in a loop, and it won't be able to do anything. So 192.168.1.1, right? So default gateway, and you can do this, right? Let's close this out and let's ping the default gateway. We can't ping through the firewall right now just because we did not enable the access lists, which will block all ICMP requests going through the firewall, and we'll adjust that later. But let's see if we can reach the default gateway. Great. VLAN 1, default gateway, all that is set. Now let me see if I can try. What I'm going to try to do is, okay, so that's set. But what I'm going to show you is that this to go to here will fail. Because here at the firewall level, access lists will, because there isn't an access list, it'll block it. So, let's see, cancel that, cancel this. And then let's try to ping 164.100.100.2. Yes. And the reason why you're getting destination host unreachable is, again, it's being blocked at the firewall level, right? Also, the firewall doesn't know how to handle default traffic, which, again, that's something that we will also need to talk about. Default traffic or default route. Cool. So here we have it set up for static. Now, what happens if I flick on DHCP? What happens then? Now, as you guys know, or as you guys may know about DHCP goes through what we call the DORA process, right? And so in this case, right, where is the DHCP server? Let me show you. If you flick on DHCP, it's requesting the IP, right? The handshake is done, acknowledged, and it gets an IP of 192.168.1.5. Default gateway being .1. But where does it get this information, right? Because within its VLAN, right, it needs to, again, go through the whole DORA process. Sorry, that sort of sounds a little condescending. DORA. It's literally screaming, I need an IP address, I need a default gateway, I need all the information so that I can go and make layer 3 requests, right? Or go out to the internet or whatever, right? But it cannot operate without an IP address. Now, one thing to know is that the end user will almost always be the DHCP client, and the server is not necessarily always a server. You can have the switch perform DHCP requests and give it the information, right? Or you can have the firewall do that and be a DHCP server. So or even a router can be a DHCP server, or you can have a server itself offer DHCP, right? In this case, the beauty of the AAC5505 is that you get its own DHCP config. So essentially what it's saying is, hey, listen, in the inside interface, I want you to give anyone that requests DHCP this IP scope, right? And in this network, the default gateway will be .1 and enable it. That's the 2 lines of config. And so that's why here you will see that it got a .5 because that's the first usable IP that it wants to give out. You can change this config. You can create an exclusion pool. You can create you can really manipulate the DHCP server to do what you want. Or you can have a DHCP server on a different network, and you can use the DHCP helper command where you can point to a server outside your network, but it's routable. But again, we're going through the basics, and just know that the ASA5505 can be a DHCP server and hand off all the relevant IP addresses and gateways to its end user. This is very, I guess, handy and useful because when we add more and more switches and routers in the upcoming video, it will help us with assigning IP addresses. Makes life easier. So in the later on we're gonna go through this, add more end users, because your company is growing, and trunking these ports and then creating redundancy and whatnot. Oh, maybe another switch here, or actually you shouldn't do that. But and then you have more routers, but again later on. Okay, so end user has an IP address. Enterprise is just doing a flat VLAN, all within the 192.168.1.1 network. Now the ASA. Couple of things you need to know about the ASA or the firewall, or so yeah, a couple of things. First, it's a beast of its own. Just, I guess, to summarize, you need to lock down your NATs, right? If you want to think about how to configure an ASA5505 in a nutshell, think of the NAT, think of the routing. I'm slowly writing this because this software is going to bug out. Routing and ACL. In its most basic, simplest pursuit of trying to understand an ASA and how to get an ASA working, assuming the interfaces are all correctly assigned, and this, I guess, security zones also assigned. Think of the NATing, routing, and ACL, and I guess you can add the security zone and interface and whatnot. But NAT, routing, ACL. First and foremost, we need to NAT it, or rather PAT it. But again, I'm not going to go too deep into this, but what you're going to do right now is create a object network group or object network, and within it we're going to throw the 192.168.1.0. We're NATing from the inside outside dynamically off the outside interface, and so we're essentially created a PAT. So we're saying, hey, take all the traffic from the inside. Remember the name ifs? We have the inside name if. Everything in the inside here, 192.168, right? And then I want you to dynamically NAT it to the outside interface here. right? So all this is going to get netted as a 10.10.2, 10.10.2 outbound. Now, that's set. We have the NAT in place. Now we need the routing, as I mentioned. So in the routing aspect of this, let's see.